أعوذ بالله من الشيطان الرجيم بسم الله الرحمن الرحيم أعوذ بالله من الشيطان الرجيم بسم الله الرحمن الرحيم आज की इस मीटिंग में फिर एक बार आप लोगों को खैर मकदम है। आज की इस मीटिंग के अंदर में मेथड्स ऑफ प्रिपरेशन ऑफ अल्केन्स स्टडी करने वाले हैं। टुडे वी आर गोइंग टू स्टडी methods of preparation of alkanes. Yesterday we have studied one of the method by the decarboxylation of carboxylic acid. Now today we will study another two methods, that is by the Kolbes electrolysis method, and second method is I'm not remembering well, Corey-House reaction. This is Kolbe reaction and Corey-House reaction and decarboxylation of carboxylic acid. These are three methods. As well as we will study some of the physical properties. Okay, so let us come to Kolbe's method. What is Kolbe's method? This method is very simple, and this method is suitable for the preparation of symmetrical alkanes. Those alkanes which contain even number of carbon atoms, they can be prepared by this method. What is done in this method? It involves electrolysis of concentrated solution of sodium salt of carboxylic acid. Sodium salt of Concentrated solution of sodium salt of carboxylic acid is electrolyzed. There is formation of alkane. At anode, there is formation of alkane. For example, when we carry electrolysis of concentrated solution of sodium acetate, ethane is formed. Here, this is general reaction RCONA. This is sodium salt of carboxylic acid. This is water. This is the solution, total solution of sodium salt of carboxylic acid. Electrolysis is carried out. Current is passed through it. At anode, there is formation of RR, that is symmetrical alkanes, alkane containing even number of carbon atoms. Sodium acetate. Sodium acetate is reacted with water molecule. Sodium acetate is electrolyzed concentrated solution of sodium salt of carboxylic acid, that is sodium acetate. When it is put to electrolysis, there is formation of ethane at anode. Two things are evolved here. At anode, there is formation of carbon dioxide and ethane. At cathode, there is formation of sodium hydroxide and hydrogen. Okay, this is the simplest method. What is done in this method? Electrolysis is carried out. Electrolysis of what? Concentrated solution of sodium salt of carboxylic acid. It is put to electrolysis. There is formation of symmetric alkane. This is called as Kolbe's method. Now come to next method. Next method is Curie-House synthesis. This method was developed in late 1960. This method is specially used for the preparation of those alkanes which are asymmetrical in nature. Asymmetrical structure means where two alkyl groups are different, R and R dash. Or asymmetric alkanes are the alkanes which are containing odd number of carbon atoms. For example, here example is given that of propane. So this method is we have seen that Kolbe's method was suitable for the preparation of symmetrical alkanes containing even number of carbon atoms. Now this method is specially designed for the preparation of symmetrical alkanes. In this method, first there is preparation of this reagent. There are two steps. First step is the preparation of lithium dialkyl cuprate. lithium dialkyl cuprate. This reagent is prepared in the first step. How it is prepared? It is given. Methyl bromide is treated with lithium bromide with lithium. Methyl lithium is formed. Then methyl lithium it is reacted with copper iodide to give lithium dimethyl cuprate or lithium dialkyl cuprate. You may write in this fashion. आप इस फैशन में भी लिख सकते हो या आप डायरेक्ट यहाँ पर भी जा सकते हो, डायरेक्ट ये रिएक्शन भी लिख सकते हो, डायरेक्ट ये दूसरी रिएक्शन भी लिख सकते हो, कोई प्रॉब्लम नहीं है उसके लिखने में आपको। अगर आप चाह रहे तो वो भी रिएक्शन आप डायरेक्ट लिख सकते हो। पहली स्टेप के अंदर में क्या होता है, ये लिथियम डाइल्क्यूल क्यूप्रेट का फॉर्मेशन होता है। और मेन रिएक्शन क्या है, व्हाट इज द मेन रिएक्शन? मेन रिएक्शन इज अल्किल ब्रोमाइड और अल्किल हैलाइड, इट इज रिएक्टेड विद दिस लिथियम डाइल्क्यूल क्यूप्रेट, reaction of alkyl halide with lithium dialkyl cuprate to give propane here. In this way, in this method, lithium dialkyl cuprate, it is reacted with alkyl halide to give alkane. Higher alkane is formed here. Here you may see that this is ethyl bromide. Ethyl bromide reacts with this lithium dimethyl cuprate. From this dimethyl cuprate, lithium dimethyl cuprate, one of the methyl group gets attached here. One of the methyl group CH3, CH2, CH3, and remaining what? LiBr. LiBr is here, and methyl lithium is also formed. Two molecules should be there. Okay. We do not worry about the balance of the reaction. Okay. In this way, this method is suitable for the preparation of asymmetric alkane. Asymmetric means those alkanes which are containing odd number of carbon atoms, and or where two alkyl groups are, they are different, R and R dash. What is this method? This method involves the treatment or reaction of lithium dialkyl cuprate with alkyl halide. There is formation of higher alkane, asymmetric alkane, and in this way you get the product. It is not necessary to mention this method, this step, but if you remember it is well. अगर आपको याद नहीं आ रहा है तो कोई बात नहीं, आप डायरेक्ट यहाँ से स्टार्ट कर सकते हैं। लिथियम डाइल्क्यूल क्यूप्रेट, it is reacted with alkyl halide to give alkane or higher alkane. Now let us come to physical properties. Physical properties means properties which can be seen easily, जिसको हम देख सकते हैं, महसूस कर सकते हैं. Those are called physical touch, which can be experienced by means of physical touch. Now first four alkanes, that is methane, ethane, propane and butane, they are gaseous in nature. Their nature is gas. Now next 13 members containing carbon 5 up to carbon 17. These alkanes, they are colorless liquids. Onwards, now those alkanes containing higher alkane which are containing 18 carbon atoms or higher alkanes, they are wax-like solids. Alkanes, they are non-polar in nature. We will see in the next physical properties. हम देखेंगे alkanes, they are non-polar in nature. Therefore, they are soluble in non-polar solvent like carbon tetrachloride and benzene. And there are non-polar, therefore they are insoluble in polar solvent like water, ethanol, etc. वाटर है, इथेनॉल, इसके अंदर में वो क्या है, insoluble. क्यों insoluble है? क्योंकि दे आर नॉन पोलर इन नेचर. नॉन पोलर है, अगर पोलर है तो पोलर सॉल्वेंट के अंदर में डिजॉल्व होगा, अगर नॉन पोलर है तो नॉन पोलर सॉल्वेंट के अंदर में डिजॉल्व होगा. ये नॉन पोलर है, इसके ऊपर कोई पोलैरिटी, कोई चार्ज नहीं है, इसलिए कार्बन टेट्राक्लोराइड है, बेंजीन है, इनके ऊपर भी कोई चार्ज नहीं है, इसलिए ऐसे सॉल्वेंट के अंदर में इजीली डिजॉल्व हो जाते हैं. स्पेसिफिक ग्रेविटी, जिसको हम डेंसिटी कहते हैं, डेंसिटी इंक्रीजेस विद इंक्रीज इन मॉलिक्यूलर वेट. जैसे जैसे मॉलिक्यूलर वेट बढ़ता चला जाता है उसी के साथ में इनकी डेंसिटी भी बढ़ती चली जाती है। Now come to boiling point. The boiling point of normal hydrocarbons increases with increase in the molecular weight. जैसे जैसे molecular weight बढ़ता चला जाएगा इनका boiling point बढ़ता चला जाएगा। As molecule becomes larger, forces of attraction between them increases, so boiling point increases। जैसे जैसे molecule का size बड़ा होता चला जाता है फोर्सेस ऑफ अट्रैक्शन उसके अंदर में जो है वो इंक्रीज होते चले जाते हैं, उसकी वजह से बॉइलिंग पॉइंट भी इंक्रीज होता चला जाता है। ठीक है, लेकिन स्मॉल केस, in case of very small alkanes boiling point increases by 20 to 30 degrees Celsius for each addition of carbon atom to the carbon chain। कार्बन चेन को हम एक कार्बन एटम ऐड करते हैं तो इसके साथ ही उसका बॉइलिंग पॉइंट 20 से 30 डिग्री सेल्सियस से बढ़ता चला जाता है। ठीक है, इन केस ऑफ स्मॉलर अल्केन्स क्या होता है, जैसे हम एक कार्बन एटम का इजाफा करते हैं, इंक्रीज करते हैं, तो उसके साथ में बॉइलिंग पॉइंट के अंदर 20 से 30 डिग्री की इंक्रीज या राइज हो जाती है। ठीक है, नेक्स्ट बॉइलिंग पॉइंट। इन केस ऑफ आइसोमेरिक अल्केन्स द स्ट्रेट चेन कंपाउंड हैज द हाईएस्ट बॉइलिंग पॉइंट। आइसोमेरिक अल्केन्स, अल्केन के जो आइसोमर्स है इसमें अगर हम देखते हैं तो ऐसे अल्केन जिसके अंदर में स्ट्रेट चेन है इनका बॉइलिंग पॉइंट हाईएस्ट है। जैसा हम देखते हैं एन पेंटेन, ये है एन पेंटेन का स्ट्रक्चर, 5 कार्बन एटम दे आर अरेंज इन अ स्ट्रेट चेन, इसका बॉइलिंग पॉइंट कितना है 36 डिग्री सेंटीग्रेड। उसके बाद आइसोपेंटेन, इसका जब हम देखते हैं तो इसका 28 डिग्री सेंटीग्रेड। और नियोपेंटेन टर्शरी कार्बन एटम, ये है टर्शरी कार्बन एटम विच इज अटैच्ड टू 4 कार्बन एटम्स which has boiling point of 9.5 degrees। For the other isomers, greater the number of branches, lower the boiling point। जैसे जैसे ब्रांचिंग होती चली जाएंगे अल्केन्स के अंदर में वैसे वैसे उनका बॉइलिंग पॉइंट कम होता चला जाएगा। In case of straight chain alkanes, boiling point is highest, and in case of branched alkanes, boiling points are lower। यहाँ पर देखते हैं इसका एन पेंटेन 36 है, ये 28 है और इसका 9.5। Now melting point, melting points also increases with increase in the molecular weight। जैसे जैसे molecular weight बढ़ता चला जाएगा उसके साथ में इसके अंदर में इंक्रीज होती चली जाएगी। मेल्टिंग पॉइंट के अंदर में भी इजाफा होता चला जाएगा, इंक्रीज होता चला जाएगा। Now come to this is the chart which is showing melting point and boiling point। Here first 4 members they are gaseous in nature, methane, ethane, propane, butane, they are gaseous in the nature। Next members C5 up to C17 they are liquids, and remaining they are waxy solids। So here melting point we can see gaseous in nature, so melting point is going to increase with increase in the molecular weight। Here 164, here 90, minus 93, minus 45, so it is increasing with increase in the molecular weight। Here you may see 36 degrees centigrade temperature, 69, 90, with increase in the molecular weight there is increase in the boiling point or melting point। Now come to chemical reactivity or chemical properties। So in chemical properties, this they are we have named this compound as the paraffins। This compound they are called as paraffins। Paraffins means having less affinity. Paraffins, less affinity, less reactive। Therefore, we find that at normal temperature they are not attacked by the normal reagents। Normal reagents like acids, alkalis, etc., oxidizing agents, they do not react or they do not affect these alkanes. So stability, they are characterized by their stability to most of the chemical reagents। The 4 valencies of carbon atom they are fully satisfied, so there is no scope for further addition of hydrogen, halogen, etc. 4 hydrogen, here 4 valencies they are fully satisfied by the four groups, four hydrogen atoms or four groups. Four atoms are attached here. So there is no chance for the addition of any other atom. So they undergo substitution reaction. Rather than addition reaction, these saturated compound they undergo substitution type of reaction. Now carbon carbon alkanes they are relatively stable to the common oxidizing agent like alkalis oxidizing agents at room temperature. Oxidizing agent like KMnO4, chromic acid, it does not even affect these alkanes at room temperature. What is the reason? The reason lies in the non-polarity of the bond. See, electronegativity of carbon is 2.6 and hydrogen is 2.1. Means there is uh, no more difference or no appreciable, no any distinct difference in the boiling point. Sorry, electronegativities. Difference in the electronegativities is not more. 2.6, 2.1 means very less difference of electronegativity is there. Therefore, bonding electrons they are equally shared. Bonding electrons which are there, they are equally shared between them, and therefore they are almost non-polar in the nature. So polar reagents they do not affect them because these are non-polar. Alkanes being non-polar, they are not attacked by the non-polar. They are not attacked by the polar reagents. Come to next. So these contain carbon, carbon and carbon hydrogen bonds. Alkane contain two types of bonds, carbon, carbon and carbon hydrogen bonds. So carbon, carbon bonds, there will be no difference in the electronegativity. So this bond will be cannot be disturbed. This cannot be broken. Both bonds, these are sigma bonds. So in order to break the sigma bonds, it will require high energy. Therefore, these reactions occur at high temperature. Whatever reactions of alkanes are there, they occur at high temperature or by absorption of light energy through the formation of highly reactive free radicals. By absorption H mu, which is shown by absorption of light energy. Some photochemical reaction is carried out, light is thrown over them, they are exposed to a typical type of light so that there is formation of formation of free radicals which are highly reactive in nature. So alkanes undergo two types of reaction at high temperature or by absorption of light energy through the formation of highly reactive free radicals. One type of reaction is substitution reaction and other reaction is thermal and catalytic reaction. Okay, we'll see the reaction in the next period. Up to this, we should know that these contain carbon carbon and carbon hydrogen bond. Carbon carbon bond cannot be affected due to similar electronegativity. However, carbon hydrogen bond may be affected at higher temperature or by the photochemical reaction through the reaction of free radicals. However, non-polar reagents, polar reagents, they are not going to affect these compounds. Okay, we'll stop here now. We'll meet with further reactions in another lecture.